Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 applied students who are looking for more help as they prepare and study for the EQAO. It's video number 4. And in these videos, we're looking at the EQAO website where they've released questions from last year's Applied Math EQAO. And I'm going through question by question and taking them up, offering suggestions, and hopefully helping you get ready for this year's EQAO. And again, feel free to post any questions or ask for different types of questions in the comment section. So we're on question 10, and it's our first open response question. So just a reminder about open response questions, they're really looking for you to re-recording what you're doing. So it's not about writing sentences, although sentences can be nice. It's about writing down any thoughts or math that you do. Anything that you punch into your calculator, you should be writing down. Anything you think like Billy goes faster, you should write Billy goes faster. Okay, so just really be fully and communicative. Okay, now let's look at this question specifically. Guzzling gas. David and Shawnees each take a 450-kilometer trip. David drives a car and uses 7 liters of gas per 100 kilometers. Shawnees drives a truck and uses 12 liters of gas per 100 kilometer. If gas costs 90 cents per liter, how much more will it cost Shawnees than David to drive this distance? So first of all, make sure you understand why I said per. This symbol right here is an important symbol because what it tells us is that 90 cents is the cost for one item, in this case for 1 liter. So that line, it's very faint, but don't ignore it. It's important. I know that 1 liter of gas costs 90 cents. So how can I use that information? And again, I'm not going to erase it because anything that you write is probably a good thinking point. So it's 90 cents for 1 liter. Well, let's look at David. David needs 7 liters to go 100 kilometers. So let's look at David and say, well, if he needs 7 liters for 100 kilometers, what would that cost him? So I think I put the question mark in a weird spot because I know that it's 7 liters per 100 kilometer, and I want to know, therefore, what is that cost? So 7 liters, each liter costs 90 cents, and in my calculator, that's $6. Ooh, pen went funny. Excuse me, that's $6.30. So I know that David pays $6.30 every. Oh, I could tell the pen was going weird there. I don't know what's going on, guys. Sorry. David pays $6.30 every 100 kilometers. So let's do the same thing for Shawnees. Again, I'm just saying I started by reading 90 cents for 1 liter, so I'm just going to keep going with it. Now, Shawnees is 12 liters per 100 kilometers. So if Shawnees drives 100 kilometers, what does it cost her? So 12 liters at 90 cents a liter is going to be, ooh, again, my pen, is going to be $10.80. So Shawnees pays $10.80 for every 100 kilometers. Now, if this is all you did in the question, you would definitely get a passing grade in this question. You've done some pretty good math, some very important math. You just, obviously haven't finished the question. So let's, I'm just going to scroll back up and look a little carefully at the question. Oh, they take a 450-kilometer trip. See, if they were to take a 100-kilometer trip, then I'd basically be done. I could just subtract and say Shanu's paid $4.50 more. But they're not taking a 100-kilometer trip. They're taking a 450-kilometer trip. So I'm going to get myself onto a fresh, clean page. And let's talk about how you might do this. And again, there's lots of different ways. Let's talk about David again. David. So David is paying $6.30 for every 100 kilometers he drives. So this is what I'm going to do for David. I'm going to make David drive in 100-kilometer chunks. So he's going to drive 100 kilometers, and that means he has to pay $6.30. Okay, David, take a break, drink some coffee. Now go another 100 kilometers. And now he's paid $12.60. See what I'm doing? I'm just adding 100 kilometers, so I'm adding $6.30. David's going to drive another 100 kilometers, so I'm going to add another $6.30 to what he has to pay. So he's now at $18.90. Go another 100 kilometers, so he's at 400 total, and he's spent in gas a total so far of $25.20. Now, the last leg of the journey is only a half leg. So this was 100, 100, 100, but this is only now a half of a leg. So if this distance went up by a half, I'm going to have to make this go up by half of what it normally goes up by. So instead of adding $6.30, I'm going to add half of that. So I'm only going to add $3.15 because he doesn't go quite the full 100 kilometers. So 2520 plus 315 means that David has paid a total of $28.35. Now, I could do exactly the same thing for Shanu's, but I'm going to show you a different method for Shanu's just because it's important that you have different choices, because maybe you don't like this method, but maybe you're going to like my next method. Oops. So Shanu's. So we know that for Shanu's, however you spell it, she pays $10.80 for 100 kilometers. So I'm going to use the multiplication method. I'm going to say, 100 kilometers is $10.80. But I want 450 kilometers. So what is my multiplication factor? What do I multiply 100 by? So here's my brain. What do I multiply 100 by to get 450? And if you don't know, use your calculator and do the opposite. 450 divided by 100, and that tells you that your multiplication factor is times 4.5. So I'm going to over here also multiply by 4.5. And that means that for Shanu's, at $10.80 per 100 kilometers, the whole trip will cost her $48.60. So again, one method was to use addition, and the other method was to use multiplication. Both of them are perfectly fine, but I'm not done the question. Again, the question said, how much more will it cost Shanu's? So it's $28.35 for David, and it's $48.60 for Shanu's, so I'm going to subtract to get my final answer. So $48.60 minus $28.35. So I'm going to do this in my calculator. Certainly not going to try that mentally. I get $20.25. So therefore, it costs Shanu's $20.25 more. Okay, hopefully that's clear. And again, I'm giving you lots of choice, and it took a long time because I wanted to be clear about my explanations. Let's go to the next question. So this is a volume question. Juice is sold in two different containers, a cone and a cube. Which container holds more juice? Circle one and show your work. If all you did was circle one and you got it right, you would get 1 mark out of 4. That's not a pass. Do the math. So they've given you the volume of a cone. Volume is pi r squared height divided by 3. And pi is 3.14. The radius of the cone is given to me as 3. So that's going to be 3 squared. H is 12. And then divide by 3. So in my calculator, 3.14 times 3 times 3 times 12 equals, divided by 3, I get a volume of 113.04 and centimeters cubed because it's volume. Now I'm going to do the other shape. So this was the first shape, and this is the second shape. And I do recommend that you label things the way I label them, because the person marking wants to know what you did. What was the logic? Now here it says the volume is L cubed, and that's because the shape is a cube. So normally for a rectangular prism, it's length times width times height. But in this case, length, width, and height are all the same. So volume is equal to 8 cubed. Now, some of you have buttons on your calculator that will do this. Some of you don't. But everyone knows that that means 8 times 8 times 8, right? 8 cubed means 8 times 8 times 8. Again, length times width times height. So in my calculator, I get 512 centimeters cubed. So which one's bigger? Obviously, the cube is. Now you might be wondering, how come the last question was so intense and took so long, and this question was pretty quick? Well, first of all, there are questions that are longer than others. But the other thing is, you'd be surprised at how many students show up to the EQAO and don't know what r squared means. They think that r squared means 2 times r. Well, it clearly doesn't. You'd be surprised at how many kids, and I'm not talking about Harvard kids, students from other places, because, you know, they've missed a lot of school or who knows why. But they don't know, for example, that when you write pi and then this, that there's little hidden multiply signs. And so some students don't know that it's multiply. So this is, you know, sometimes a challenging question. But I think for most of my students and for Harvard students in general, this is the sort of question that we really like to see because it's very straightforward. Let's see if we have time to go forward to the next question. Oh, good, it's multiple choice. The graph below represents the relationship between number of calories and volume for various drinks. Which of the following points represent a drink with more calories than expected for volume? Now, the phrase "than expected" is talking about the trend. So if we expect something to happen, it's because there is a pattern or a trend, right? I expect it to get cold in October because that is the pattern of the seasons. I expect to have to do laundry every Sunday because that is the pattern of my clothing wearing history. Weird? I don't know. So what is the pattern on this graph? Well, there is clearly a trend or a pattern that looks kind of like this. It's called a line of best fit. A line of best fit shows you the trend. It shows you the pattern on the graph. So, which of the following points represents a drink with more calories than the trend? Well, look at that red line. Wow, Q has more calories than I expected. That's the answer to this question. So I'm hoping that one's a pretty easy one. Maybe the vocabulary is weird, but now that you understand what you mean by expected, I expect to see the pattern. Okay, so that's the end of video number 4, and I will meet you in video number 5.